Okay. First, a sales pitch. Okay. So, what do you mean a sales pitch, Mr. Green? All right, so numbers are only half of a measurement. Okay, so our goal of a measurement is to describe the world. And if I tell you something is 10 long, what does that tell you about it? What have you learned about the thing I just told you about? Well, all you know is bigger than 9 long, but if I asked you to put your hands that far apart, put your hands 10 apart. You see why you can't do that? 10 what? Okay? So, numbers without units are meaningless. Okay? So what does meaningless mean? Well, meaningless means they have no meaning. Okay? That's what meaningless means. They have no meaning. How do teachers treat answers that have no meaning? How'd you expect them to treat answers that have no meaning? We marked them wrong. Okay? So on the homework assignment, quite a few of you forgot to work with the units part of it. Numbers without units are meaningless. That means they're incorrect. Okay, so we need units because otherwise we can't make any meaningful discussion with our numbers. Okay, second piece. How many feet are in a yard? I know it's a trick question. It depends on how many people are standing in it. But no. Everybody knows it's 3 feet in a yard. Okay. So that's the system we use. Okay. Fewer people are familiar with this one. How many feet are in a mile? Track athletes tend to know because they count every yard every mile they run. It's 5,280. But the English system has some obscure units too. How many feet are in a rod? A rod is an English unit. Okay. Anybody know? Okay, the only place I've ever seen it used is when you portage a canoe. Okay, when you're canoeing, I grew up in northern Michigan, so I know canoeing. So when you're canoeing and you're going from one lake to another, you have to carry your canoe. And that carrying your canoe is called a portage. It spells like portage, but it's called a portage because it's French. Okay? And when you go to a national park, they tell you how long your portage is in rods. That's what they measure it in, which is bizarre. I don't know why they chose that. But a rod is 16 and a half feet. That's its definition, 16 and a half feet. So, English system. We love it. We use it all the time. Just minor little problems like that. Problems. What if I asked you how many rods were in a mile? Could you do that in your head? Could you do that math in your head? I know I couldn't. So, converting in the English system is hard, and they've got bizarre conversions. I mean, got 3 feet. Why 3? I don't know. Why 12 inches? I don't know. Somebody arbitrarily chose that stuff. Actually, I do know the 12. Okay, the reason why they picked 12 is because 12 is an easy number to divide in half, in thirds, and in quarters. So that's why they picked 12. It's because you can cut it in half, you can cut it in thirds, and you can cut it in quarters really easily. Okay. But the metric system saves you a lot of work in this thing because the metric system is a decimal system. Okay? And a decimal system means that every conversion is some power of 10. It's either 10 or 100 or 1,000 or 1,000,000 or 1,000,000,000 times bigger or smaller. And I can do math with tens in my head. So here's the history. Okay? Metric system came out of the French Revolution. Okay? And the reason why French Revolution wanted to base everything on nature. Okay? And they wanted to get rid of everything tied to the monarchy. Well, what was the foot? Well, the foot was the length of the king's foot, which caused some problems. Because when you got a new king, you got a new foot. All your measurements changed. And when you went from one country to another, they had a different king. So their foot was a different size than your foot. That's going to cause you some difficulties along the way. I hope you understand that's not a great system for trade. So the French Revolutionary said, we're going to get completely new measuring system, and it's going to be based completely on things we can measure in nature. Okay? And we're going to make it so it's easy to use. So obviously France was the first country to agree to go metric because they invented it. The second country, the United States of America. We were good friends with revolutionary France. They helped us during our revolution. We helped them during theirs. So we were good friends with the French. And so Thomas Jefferson, when he was Washington's Secretary of State, signed a treaty with France saying the United States would go fully metric. We didn't quite follow through. I think the only place we've really gone metric is in our sodas. We buy them by the liters. That's the only place you really see metric stuff. Okay? Right? But in 1875, they officially, the world officially adopted the metric system. And by the world, I mean every country except 3. The 3 countries that don't use the metric system as their official one are the United States, Liberia, because Liberia was formed by former slaves, so they brought the U.S. system with them, and Myanmar. I don't know why Myanmar wouldn't have changed, but those are the 3 countries that don't use the metric system. So we're at a big disadvantage. We have to have 2 sets of tools. The rest of the world only needs 1. Okay? So that's where the metric system came from. Now we're going to talk about how to use it. Okay? A metric unit has up to 2 parts. Okay? It has to have a base unit. It might have a prefix. So everyone has to have a base unit. Most of them have prefixes. And the prefix tells you how many times to multiply or divide by 10. That's what it does. So we're going to say, here's the base unit, I want 10 of those. Or here's the base unit, I want 1/100th of that. Okay? And that's going to be an easier conversion because we can do math with tens in our head. So here's the base units. Okay? The base unit of length is the meter. Okay? And the meter is a little bit bigger than a yard. The abbreviation for meter is lowercase m. Now, the original definition of the meter was 1/10 millionth the length, the distance between the North Pole and the equator through Paris, France. That was the original definition. Now they've changed the definition of all these things so that they're all based on things completely in nature. So the meter is actually how far light will travel in a certain amount of time. A really tiny fraction of time.
Hello.
Hello?
Hi, this is Shari's mom.
Yes. Okay, well, you're interrupt.
Actually,
What can I do for you?
yeah, I'm sorry. She's sick right now.
Okay.
She's in the bathroom
Okay.
throwing up.
Okay, so everything here is going to be recorded, so I'll put that up on the canvas for her and tell her I hope she feels better.
Okay, thank you
You
so
think?
much.
Thank you. Sorry about that.
All right, bye-bye.
Bye. Okay, so meter, a little bit more than a yard. So we're going to use that to measure how long things are. Mass. Mass is the gram. Sometimes it's the kilogram, just depends on who you talk to. And a gram is about the weight of a raisin. A gram is a tiny mass. And the abbreviation for grams is little g. All these are case sensitive, so watch out. The unit of time is the second. And it's abbreviated lowercase s. And the time is the one place where we didn't go completely decimal. Even the French didn't, because the French, when they designed their metric system, they made a metric day, and they divided that day into 10 even pieces, and they call those 10 even pieces. Divide each one of those into 10 even pieces. So their clocks were things like based on tens, and they built clocks like that. And they put them up in towns. But when they put them up in towns, they were right next to the churches that had the old clock. And nobody looked at the new clock. And nobody was willing to tear down the church's clock. So since since they couldn't talk anybody to take care of the old clock, that's why we have 60 seconds is a minute, and 60 minutes is an hour. The reason why we have those is because that came out of Babylonian math. In Babylon, their math system was base 60. Like ours is base 10, theirs was base 60. That's where it comes from. So do some Babylonian math every time you turn seconds into minutes. Temperature is either Kelvin or degrees Celsius. Kelvin doesn't get a degree sign. Celsius does. The abbreviations are capital K and capital C because capitals are used when the unit is named after a person, except in one case. So there was a Kelvin, Lord Kelvin. He studied heat. There was a man whose name was Celsius. He invented a thermometer. Okay? So they're capitalized because they're named after people. The official unit of energy is the joule, named after Robert Joule. That's why it's a capital J. We will use one that's close, that chemists like this one, something you probably heard of before, the calorie. And calorie is abbreviated cal, C-A-L. So we'll use joules and calories to talk about energy. The unit of volume is the liter. And a liter is about the size, about half the size of a 2-liter bottle. Well, duh. Half the size of a 2-liter bottle. So liters is something we actually have a feel for. A water bottle in your hand. That's a liter. Now, liter is capitalized not because there was anybody named Liter. It's a problem with typing. If you write 21 liters, everything's okay. But on old typewriters, the lowercase l and the 1 look the same. So if you wrote a lowercase l, it would look like 211. And it would be hard to tell the difference between 211 and 21 liters. So that's why they don't use a lowercase l, they use an uppercase L, is so that we can make sure that it says liters. And here's one you haven't heard about, but we're going to use a lot in chemistry. The amount of substance, how much stuff you have. And we're going to measure that in moles. Now, mole is one of the shortest names, but it has the longest abbreviation. All you do is leave off the E. So these are our base units. This is where we start. And then we're going to either say it's either this size, or it's 10 times this size, or it's 1/10 this size. And we're going to do this by adding prefixes. Now there's lots of prefixes. I'm going to tell you the ones I need to know, that you need to know. The prefix kilo, its abbreviation is a little k, small k, and it means 1,000 times bigger. So a meter is about a yard. A kilometer is 1,000 of those laid together, and it's about 6/10 of a mile. We're going to skip one of the prefixes. We're going to skip the one that we're going to skip a couple of prefixes. We're going to skip hecta and deca, and we're just going to do deci, decimal, deci, 1/10. And that means it's smaller. So the fraction ones are smaller than the base unit. Actually, kilo is the only one we're going to use that's bigger than the base unit. All the other ones we're going to use are smaller than the base unit. Okay. So, I don't know if you've heard the phrase decimate. Well, what that literally means, mate, for those of you speaking Spanish, mator, kill. Deci means 1/10. So it comes from the fact that the Roman legions had 100 people in their legion, and if they messed up, if they lost honor, they would decimate that legion, which means they would kill 1/10 of the people. That's where decimate came from. It was a punishment for a unit that didn't do its job. Here's one you should know. It's one we actually use all the time, centi. Okay. Its abbreviation is a little c. It means 1/100th, because a cent is 1/100th of a dollar. Fact is, this actually talks to you about that the U.S. was close to France. The United States, when they formed, they were the first country to have decimal money. The first country to have a decimal point in their number, or in their money. It used to be like 20 pence to a shilling, so many shillings to a guinea. I don't know all those numbers. They used to have just, money used to be about trading coins, and the U.S. figured out, no, it's better to do it decimal. So a cent is 1/100th of a dollar. Centime means 1/100th of whatever you're talking about. So a centimeter is 1/100th of a meter, so it's going to be a little ing, and we're going to use that about where we use inches. Prefix milli, little m. Milli means 1/1000th. For those of you taking either French or Spanish, this should be easy to remember. Because how do you say 1,000 in French and Spanish? The answer is the same, by the way. It's mille, right? So mille means 1,000, milli means 1/1000th. Okay. Micro. You may notice that we had to use an M here when we already used an M before. We run out of M's. So micro had to come up with a letter that was M, but not an M. So they went to the Greek alphabet, and they picked this letter. This letter is called mu. 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 It's the equivalent of rm. Fact is, over time, people started writing it faster, and it became rm. Okay? So letters evolve over time too. So this mu became our n, but it's m. So it is the m substitute for micro. Micro means 1/1,000,000th. Think of what you would look at through a microscope. Okay? And one that's actually come up to be pretty important over the past 8 months, nano. Nano, with the abbreviation little n, means 1/1000,000th. Okay? So when they talk about N95 masks, the N in N95 is nano. For nanometer, because those masks are designed to filter out nanometer-sized particles. Okay? And the 95 is 95%. So they're designed to filter out 95% of the nanometer-sized particles, which is the size of viruses. Okay? So nano is really tall. And you hear it discussed in things of nanotechnology. That means they're making things the size of viruses. They've made little electric motors the size of viruses. They're making machines and designing things at that scale. That's pretty amazing. So here's how it's used. When I see kilo and meter, I think of meter is about this long. Kilo means 1,000 of them. That's going to be a big distance. That's why I knew it was going to be a big distance, about 6/10 of a mile. Centimeter. I got a meter, and I'm going to cut it into 1/100th its size. So I'm going to take this big meter stick and cut it into 100 pieces. I'm going to get pieces about that big, less than half an inch. But they use centimeters where we use inches. And millimeter is about the width of a wire on a paper clip. Because if I took a meter stick and cut it into 1,000 thin little pieces, they'd all be about as wide as the wire on a paper clip. Not the whole paper clip, just the wire. How wide that wire is. Okay, so got a few questions for you. Put the following in order of increasing size. Now, you got to learn to translate those questions. Increasing size means the next one's bigger. Okay, so you start with the smallest and end with the biggest. What order would those go in if you started with the smallest and went with the biggest? Went to the biggest. Well, put meter in the middle. Hey, which one of those are bigger than meters? Millimeter? Width of a wire? Nah. Kilometer? 1,000 meters. Yes, kilometer's bigger. Centimeter? 1/100th? Nope. Micro? 1/1,000,000th? Nope. So the only one bigger than kilometer or meter is kilometer, so that's got to go at the bottom. It's got to be the last one because it's the only one bigger than meter. So now I got to think about the things smaller than meters. Okay? Which of these prefixes is the biggest? Well, this is 1,000th. This is 100th. This is 1,000,000th. I'm too lazy to write 1,000,000, so I write 10 to the 6th. I'm not writing 6 zeros. So the smallest of those would be the one divided by the biggest number, so I'm going to start with micrometers. Then between centimeters and millimeters, 1/100th is bigger than 1/1000th, So centimeters goes here, and millimeters goes in between. So I go millionth, thousandth, hundredth, 1,000. See how it would be easier to change centimeters into meters than it is to change inches into feet or inches into yards. Because you're only going to have to do math with 100, and you can do math with 100 in your head. Okay? Math with 36 in your head isn't as easy as math with 100 in your head. Okay. So a liter is about 1/4 of a gallon. Wasn't until late in life that I figured out that they called a quart because it was 1/4 of a gallon. So this is a liter. You can see my picture, that's a liter. So a milliliter is about 20 drops of water or a sugar cube. Now, for volume, there's actually a second way we can get volume. There's two ways to measure volume. You can measure it with a measuring cup, or you can measure it with a ruler and do length times width times height. That's area. Well, length would be in meters, width would be in meters, height would be in meters. So I'd have meters times meters times meters, and I'd get meters cubed. Now, you'd think that that's what they'd use in the metric system, but it isn't. And here's why it's not. Okay, picture a box 1 meter wide, 1 meter tall, and 1 meter deep. That's a cubic meter. When you go to the store, how many cubic meters of soda do you want to buy? Does it make sense to sell soda in cubic meters? No, it's just way too big to be convenient. So they picked a smaller cube. They picked a cube that was 10 centimeters on a side. Okay, so this is a liter. Okay. Let's see if I can get this to show up a little bit better. So I've got is a cube. And along this side, it's a decimeter, which is 10 centimeters. Along this side, it's 10 centimeters. And along this side, it's 10 centimeters. That's a liter. Okay? Take me to your liter. It's right here. Okay? So that's how big a liter is. That's how they defined it. Okay? But that leads to math. Okay? That leads to math. So, 1 liter is 1 decimeter times 1 decimeter times 1 decimeter, so that's 1 decimeter cubed. 1 cubic decimeter. But since a decimeter is 10 centimeters, I could write that as 10 centimeters times 10 centimeters times 10 centimeters. So a liter is 1,000, 10 times 10 times 10, centimeters cubed. Centimeters times centimeters times centimeters. So when you see a length cubed, that means you're talking about a volume. What would it mean if I saw centimeters squared? What would I be talking about then? Well, to get centimeters squared, I would take one distance and multiply it by another distance. That would be a length times a width. So centimeters squared would be area. So cubes are volumes, squareds are areas. Okay, now for an algebra trick. I'm going to divide both sides by 1,000. So that 1/1000th of a liter is 1 centimeter cubed. But we have another name for 1/1000th of a liter. We have a prefix that means 1/1000th. A milliliter and a centimeter cubed are the same size. So liters and centimeter cubed are tied to milliliters and centimeter cubed are the same size. There are 1,000 milliliters in a liter. There are 1,000 centimeters cubed in a liter. So that means each milliliter is a centimeter cubed. So this right here is how we change from things measured with graduated cylinders to things measured with rulers. Okay? So I can compare the thing I did with a ruler to the thing I measured with a graduated cylinder. I can change what measuring technique I'm using, in effect. Okay. Mass. We said it was the gram. A gram is back to that centimeter cubed. So the gram was defined as the mass of 1 centimeter cubed of water at 4 degrees Celsius. Why 4 degrees Celsius? Well, that's when water is its most dense. Any temperature other than 4 degrees Celsius, it's going to be less dense. That water's density changes with temperature. That's why when you jump into the pool, the bottom is cold. It's cold because the denser water is going to end up at the bottom and the colder water is denser because you're not swimming in a pool that's 4 degrees Celsius. Not for very long. Now, I multiply both those numbers. 1,000 grams would be 1,000 cubic centimeters. So if you want to feel for what a kilogram feels like, it's the weight of a 1 liter water bottle. Oops. So a kilogram of water is 1 liter of water. So if you've got a liter soda, it weighs about a kilogram. And a kilogram is about 2.25 pounds, 2¼ pounds. That's about how heavy a water bottle is. You don't have to know these between kilograms and pounds. I'm just trying to give you a feel. So it's something heavy. A gram is about the weight of a paper clip or a raisin. At least that's what they told me on Schoolhouse Rock. A milligram is the weight of about 10 grains of salt. It's tiny. Okay. So those are the pieces of the metric system. that we need to use. So now, what I need you to do. When you go to Canvas, there's an assignment called metric estimates. Okay, and what it's going to be is, it's going to be a list of things, and it's going to ask you to estimate what metric unit you would use. Would you use a meter, a centimeter, or a kilometer? For example, if I asked you to measure the length of this pen, what unit would make sense? Would it make sense to measure this in meters? Well, a meter's much longer than this, so I wouldn't want to use a whole meter. What would I want to use? Well, I'd want to use a smaller part. I could use a decimeter, because this may be 1, or I could use a centimeter, 1/100th. So you need a unit that's smaller than the thing you're measuring, but not so small that you get millions of them. Okay? So I'm going to send you a breakout room and see if you can agree on what unit you would use to measure those things. Everybody understand what you're going to do? Got it? Okay. Off you go. Hey, welcome, folks. Sorry. Got engaged and stuff. So, let us see how that went. There we go. Okay, so here's the questions you answered. So, what would be the SI unit for expressing the length of the following? So the fact that it said length right there means that all of these should have the same base unit. Should be meters. So you think about a meter is about a yard. So if I'm going to measure the width of a gymnasium, I need a lot of meters. But not hundreds, not thousands. So I wouldn't measure it in kilometers, but I would measure it in just meters. The length of your finger. Would it make sense to use meters to measure the length of your finger? Nah, because you have a tiny fraction. So I need something smaller than a meter. And you could, I would think if I would measure my finger in inches, every time I do it, I replace inches with centimeters. Okay? This is between your town and the closest border of the next state. Well, that would have to be Arizona, because it's straight west. Yeah, because you got to go north to go to Vegas. So, but what would you measure it in? Well, that's going to be lots of meters, and we only have one that means lots of meters. That's kilometers. And the length of a bacterial cell, what would you use to look at a bacterial cell? You'd use a microscope, right? So what unit do you think you would be using? How about a micrometer? Okay. If you use a microscope, you're going to look at a micrometer. Microscopes can't see viruses. They're too small. So you would need a smaller unit, the nanometer. Okay. Okay, it says what would be appropriate for measuring the mass of each of these. So it's got mass in it. Everything's got to be in grams or some prefix with grams. So you want to compare everything to a raisin. So a table. How many raisins would it take to equal the weight of a table? It would take a lot, right? So we're talking kilograms. The only prefix we have that's bigger. A coin. A coin is about the same as a raisin. They're in the same ballpark. They're about the same size, so I would use grams to measure a coin. A 250 milliliter beaker. Well, if I had a 250 milliliter beaker, piece of glass, that's a cup. What would you use to measure a cup? Well, it wouldn't be kilograms, because this is not as heavy as a thousand raisins. So it's got to be just grams again. Okay? Because we tend not to use the two in the middle, the hecta and the deca. Now I said we tend not to use them. That doesn't mean that they don't exist. We just don't use them. Fact is, we're going to have to use them here in a second. So, back to this. All right, so now what we're going to be able to do is we're going to show you the real power of the metric system. And the real power of the metric system is in converting. If I asked you how many inches in 7.3 miles, you could not answer that in your head. You need a big piece of paper to do longhand multiplication, or you'd need a calculator. Okay? This table right here will help us convert. Now, when I learned it, it was kids hate doing anything during cold mornings. That's how I remembered it. Or King Henry died, space, drinking chocolate milk. Okay? Just have to remember the order. And what these stand for, some of them should be familiar. The K is for kilo. The little d is for deci. Little c is for centi. Oops. And little m is for milli. So those prefixes. Here's the two prefixes we don't use, hecta and deca. Deca is 10 times bigger, hecta is 100 times bigger. We tend not to use them every day, but they're there. There's lots of prefixes we don't use. There are prefixes bigger than kilo. They use them in the computer industry. Kilo means 1,000, mega means 1,000,000. Giga means 1,000,000,000. Tera means 1,000 billion, 1,000,000,000,000. Peta means 1,000,000 billion. Okay? There's all sorts of other ones. They're listed in your book. So if you come across an unfamiliar prefix, there's a list in your book that has most of them. Okay. So we need this chart because this chart is going to make converting easy. Because how far you move on this chart tells you how far and which direction to move the decimal point. And what goes in the box is anything, any base unit. So if I'm talking about meters, then this is decimeters, this is centimeters, this is millimeters. If I'm talking about liters, then this is kiloliters, this is milliliters. So anything can go in the box. So kids hate doing anything during cold mornings. So, change 5.6 millimeters, or meters to millimeters. Okay? So my base unit is meters, so millimeters is over there. I'm starting at meters and going 2 millimeters. So to do that, I'd have to move 1, 2, 3 to the right. So I start at the base unit and I move 3 to the right. That's what I have to do with the decimal point. Decimal point starts here and I have to move it 1, 2, got to put in a placeholder, 3 to the right. So that 5,600 millimeters is the same size as 5.6 meters. Wasn't that easier than going from 5.6 yards to inches? I think so. I think that was easier. So that's the whole technique. Count and move. So convert 25 milligrams to grams. See, here's the real beauty of the metric system. You don't have to repeat. You don't have to learn a new one. When you go from length to weight, you don't have to learn that there's 12 inches in a foot, but there's 16 ounces in a pound. Okay. All right, so here's how you do that. 25 milligrams. I'm starting with milligrams and I'm going to grams. To do that, I'm starting at milligrams, so I'm starting here, and I'd move 1, 2, 3 to the left. So I take my 25 and I move it 1, 2, 3 to the left. 0.025 grams. Notice that I started off with 2 sig figs and I end up with 2 sig figs. Because I put in a 0, but that 0 is in a place that doesn't count. Same with the last one. I started off with 2 sig figs, 5.6. I ended up with 2 sig figs, 5,600, because you put it You're putting the zeros in the places where they don't count. So any zero you put in when you do this won't count. Change 0.45 kilometers to millimeters. So both of these have M in them, so we're talking about the base unit being meters. And I want to go from kilometers to millimeters. So I want to start at kilometers, and I need to move 1, 2, 3. You count the box. 4, 5, 6. And I need to move it 6 to the right. So I start off with 0.45, and I move it 1, 2, 3, put in a 0, 4, put in a 0, 5, put in a 0, 6, put in a 0, and I get 450,000 millimeters, 0.45 kilometers. Here's another relationship that works, and it's something we've talked about before. What happened to my unit? I went from kilometers, which is big, to millimeters, which is small. My unit got smaller. So my number has to get bigger. It has to take a lot of little pieces to equal a few big pieces. So just like scientific notation, where if one part got small, the other part got big, same thing happens here. If the unit gets bigger, the number gets smaller. So if you make a mistake, it's usually that you that you change it the wrong direction. So a quick check at the end. I went from a big unit to a small unit, so I should go from a small number to a big number. They go opposite directions. Okay, it's not a magic chart. It's not a magic chart. It's really because we're multiplying and dividing by 10 the right number of times. If there are 1,000 meters in a kilometer and 1,000 millimeters in a meter, then I should take that 0.45 and multiply it by 1,000, and then multiply it by 1,000 again, and that's where I get 450,000. That's all the math I did behind it in the back by moving that decimal point. So you're doing math by moving decimal points. So try this one. Go ahead and finish that up and see what you get. Just to make sure you can do these okay before I send you off on your own. So you should have gotten 15,000 centiliters. And a quick check. Centiliters are smaller than a meter. Kiloliters are bigger, so I'm going big here. My unit's getting bigger, so my number, or sorry, I went the other way. No, sorry, I went the other way, didn't I? Got my arrow the wrong way. I went from kiloliters to centiliters, so my unit got smaller. So my number has to get bigger. So the unit gets smaller, so the number gets bigger. What about micro and nano? Well, when I got micro and nano, I've got to change my chart. I've got to add them to the same end as milli, because milli is smaller than centi, micro is smaller than milli. Nano is smaller than micro. And the jump in between, the only difference is this is 1,000 and that's 1,000,000. So I got 3 zeros. So my jump here is 3. So that jump is 3 places and then 3 places, because this goes to 1,000,000,000. So all you got to remember is that micro and nano have a bigger jump, because the exponents on all the prefixes, after you get past 1,000, they always go by 3s. So kilo is 1,000, mega, the next one, is 1,000,000. So if I asked you to convert 15,000 micrometers to meters, my base unit is meters. I got micrometers here. I want to start off with the micrometers and move to the left to get to meters. That would be 3, 4, 5, 6. So the first jump is 3, 4, 5, 6. And it's to the left, so I take my 15,000 and I move it 3, 4, 5, 6. I get 0.015. I need to leave those zeros off because they would be significant figures, because it's after the decimal point. But the 0 I put in is not. Now, does that make sense? Micrometers are tiny. Meters are big. So my number is getting much bigger, or my unit's getting much bigger, so my number has to get much smaller. My unit's getting much bigger, the number's got to get much smaller. Okay, so we use the chart the same way. We just got to take big jumps between milli and micro. And go ahead and convert 0.00035 centimeters to nanometers. Well, I'm starting off at centimeters. That's where I start. And I want to go to nanometers. My first jump is 1. Then 3 more is 4. Then 3 more is 7. So 7 to the right. So 0.00035, and I move it 1, 2, 3, 4, 5, 6, 7. So I got to put in 2 zeros. So I get 3,500, and I keep the zeros because I need the placeholders. That's nanometers. Did it change the right direction? Centimeters went to nanometers. My unit got much smaller. So my number has to get much bigger. Pretty simple technique. Okay? Much easier than the English system. Okay? Now, scientists use the metric system because they want to communicate with the rest of the world. So while they're working in their labs, they're using the metric system. When they go to the meat counter, they buy stuff in pounds. So scientists are forced to switch back and forth. The rest of the world just gets to use the units they're used to all the time. So one last check, and then I'll set you off to work on the metric practice. Okay? So how many nanograms in 1,300 thousandths of a milligram? Wow. Don't say those numbers out loud very often. 1,300 thousandths. Go ahead and see what you get for an answer and see if it matches up with me. Okay, what I got was 130 nanograms. Because I'm starting at milligrams, made one big jump, 3, 2 big jumps, 3 to get to nanograms. So I took one big jump, 2 big jumps, means I got to put in a 0. I could have counted all 6 of them. And that's where I got the 130 from. Reasonable? Okay. So what I'd like you to do is you can go to Canvas. The metric practice should be up and ready. Go ahead and start working on that. And actually, scan ahead. See, try a couple of each of those problems. Start, at the beginning, and see if you know what you're going to do on the whole assignment, so that you can ask me questions before you leave in the next 5 minutes. None of those questions should take you very long. All of them should be pretty easy. But we had to give you the system we're going to use. So go ahead and work on that. Okay, folks, I gotta let you go.